Now, diving into details, large language model and retrieval augmented generation. What are they? Large language model is a particular machine learning model that can comprehend and generate human language text, and what's behind it is it's a collection and the statistics of existing human archive. So you go to internet, you go to some the large language model, large language set like the Congressional Library text. You get all these related text, words, and their relationship with other words. You collect all the statistics together, and when someone user try to retrieve a word, by statistics, what the words are going to come together with that word. So this is what essentially a large language model is. But then there's also an enhancement of retrieval augmented generation, which is this word augmented mean, right? It's enhance, enlarge of this already large language model. The RAG, the retrieval augmented generation, optimizing the output of a large language model. So it references an authoritative knowledge base outside of its training data source before generating a response. So we all know that the large language model has been there for a while and the research has been there, but it gets popular when OpenAI come up with is a ChatGPT, right? What OpenAI does, it integrates LLM into existing frameworks, um, so that when you input something, OpenAI's chatbot can take your words, matching that into their large language model, the GPT model, and come back with the model output. The issue with large language models the limit is that something called hallucination, which means sometimes it will just giving out the answers that makes no sense or it's wrong. I have this experience because I tried out ChatGPT a lot, and many times I do know its answer is wrong. Well, the way I look at it, I didn't have a strict statistic on that, but what I see is if I generate one page of a legal of I mean of a letter-sized Word document. In a Word document, if I copy the answer from ChatGPT, for each page, there's about like one clear mistake. That's my estimate based on my experience. Then you would like to do certain chunking and embedding for large language models answers, and you will use a similarity processing. This is what we are going to talk about next. So the limitation. What's the limitation? The limitation is, first of all, the GPT model in general, the large language model, not necessarily only the GPT, but basically all large language model is generic, is a general purpose large model. If you want to specifically limit your language to your answer to a certain area, it has hard time doing that. Some of you actually try that. If you look back to the first question in our week one, I was asking you what are the three types of cloud. Now, interestingly, uh, the real cloud in the sky, they also have three types. So this is actually a trick question I designed there. Some people, if they do not really listen to the class and just run the ChatGPT to get the answer, very likely they will get the answer on the of a natural cloud, the three types natural clouds, and you will get a 0 for your answer because you are not even looking at what the what the question really asks about, right? And although this is a large language model hallucination, a large language model issue, you will take a consequence and get a 0 point. That being said, like here, if I ask, what does this course teach me? ChatGPT has no idea what you can do, what you are looking for. So he or she said, I need more specific information about the course you are referring to. What can you do though? Is chunking. From this language, from DS684's syllabus, I took a part of this course teach, right? That this desired outcome. So after, what does this course teach me? The desired outcome of the course is the student ability, etc., etc. This is one paragraph I took from syllabus. Once I provide this to ChatGPT, it start to understand what I'm asking for and the context of the question. That's it start to say, of course, you describe aim to teach students how to apply conceptual knowledge of cloud computing to practical situations, which is exactly what we're doing here, right? And it comes up with more information. As you see, I didn't talk about like cloud service models like IaaS, PaaS, SaaS, etc. But it comes up with all this based on the input I gave. What is that? What is that course about? About cloud computing. Okay. So you should. So if you want to utilize large language model in any of your actual circumstance, you want to provide related information. And where do you get this related information? You should have a set of a trustworthy information, which forms your knowledge base. You get your some extractions from your knowledge base related to your question, supply both your question and those extracts, those most relevant subtracts from your knowledge base together, question, subtracts, supply them to a large language model, and you have a much higher chance of getting something is truly related. So this is just a demo. Let's say you have a knowledge base, you have a text corpus. All the data you have, all the text you have that is related to your to your subject. For example, the syllabus of DS684 plus possibly the language, the video recording, the speech coming from this video recordings. You get all this text. You chunk them into small pieces. The larger that your chunk you are, the accurate it will be, but it will give you less chunk. So there's a trade balance. Then you convert them into embedding, which is the mapping. Embedding is what they call the mapping between words and the model. So in the model, they don't store the words directly. They use some embedding. They use some code to store the word token to store words. So this word ChatGPT may be mapping to a certain token, and this great or conversational tool, all this mapping to a certain token. This is where you convert those text into those token designations. That's where you get the vector embedding. Now you have all these embeddings in this vector database where you break up your text corpus into a series of embedding vectors. Now you have this large language model as well as your text corpus saved together with the same language that the computer can understand, right? In the same language that this model use, they store side by side. And that text corpus embedding is now your knowledge base. What are you going to do is you do similar processing. When you ask a question, you will try to search, find the top three n vectors. The top three, here we use, in most cases, people use 3. So you want to find the top 3 in vectors that's most similar to your question, most relevant to your question. Then you have one question plus 3 extractions. That's when you supply these 4 items into large language model to get the context, to get the answer, which is definitely more relevant than if you only submit your original question. So this is the system diagram example. This actually is one system that I designed before we run some initial testing. Try to get some startup idea. That one didn't work out, but that's basically what it does. So so in the front end, there are 3 pages. You can do file upload page, there's administrative page, which only controls all these configurations, right? But first of all, you will upload your text corpus. After you load the text corpus through Amazon API Gateway, there is a Amazon AWS Lambda does the chunk embedding, splitting your file into smaller pieces, convert them into embedding vectors, and save that into a vector database, which is here in this example is a Pinecone. Now, in your user interaction page, you will enter your question, right? Also through Amazon API, and Amazon Lambda will send the question to Pinecone and retrieve the top 3 vectors that are most similar to your question. Now you have the question plus 3 vectors, 3 text knowledge base vectors. Submit them to LLM, get the answers, coming back. Excuse me. And we have some relational database here, just saving the original text for reference. And that's just how you get your answer. Now, pushing one step forward is Copilot. Microsoft, as we all know, has a very strong presence, dominant presence in the Office suite. Office suite is something that human beings interact a lot with customers, with the computer, right, with the machine. So this is what Microsoft is trying very hard to reduce the energy, or to reduce save the time that human beings needed to interact with Office Suite. So Microsoft has its own LLM AI, which is LLM AI powered chatbot, aiming at helping users using different Microsoft products. For example, one example of how this can be a workflow can be managed in an easier way and save you some time. For example, you are having a customer meeting. You will prepare a meeting by research on previous emails. So what is previous emails? It's a bunch of text, right? And then we will start from here, getting discussion topics, getting customers' concern, getting answers. In the meeting, you will have recordings, and the audio can be converted to text so that you, without any effort, get the transcript of that meeting. So what ChatGPT does, what the Copilot can do, is to summarize the meeting minutes, and from these meeting minutes, who said whom, getting an action item. And then it will summarize action item results by going through the document you follow. If you put all these into the same Office suite folder, you have, because every time after a call, you probably have a Word document, you have a GitHub code, you have Excel spreadsheet. All these artifacts can be placed into the same folder. You ask this Copilot to go through this and summarize the result of your action item. Write a follow-up email. Then this can goes on and go. Now, this is what I interpret the Microsoft vision. This is not the Microsoft vision. This is my interpretation of based on what I heard from them discussing. But as you can see, there are a lot of things that you can do that currently people are not doing, but that would like to have, right? So this is, of course, the fancy way of how future could be, right? But even now, there are things that Microsoft is pushing out. So, for example, Office Copilot, Excel, or Word. Example is, if you get this, everybody is familiar with this price, right? With this Excel spreadsheet grid. If you use Copilot, you can start. Copilot can identify key trends. Sales are trending up, manufacturing costs are down, etc., etc. It can also give you visualizations. So it will help you streamline the workflow. This is one part. In previous previous slides, we talked about they can summarize action result. But even within the action, it can help you to identify what is related, what things you may be interested in. Now, It can also provide you with help with relative with the related information. For example, this is a VS Code, and it can provide you with GitHub Copilot. When you connect to GitHub, GitHub can provide you with advices such as, what if I want to write a bubble sort? Now, what if I want to convert this to use quicksort? I have already got a bubble sort. I want to convert it to quicksort. Copilot can help, right? And there's something called AI Studio. I was trying to get a screenshot, but this is too late, too new. It's still in the making. It's still in preview. So I'm not putting here. But by the time you land your job, it's probably there. So you just be aware there is such a thing called AI Studio.